Right. This is going to be a demo of chat.fullstack.cash. This is going to be a two-part demo. This first video is just going to demonstrate how to use chat.fullstack.cash, which is an uncensorable peer-to-peer end-to-end encrypted chat app, and emphasis on the uncensorable part and the end-to-end encrypted part. And it's built on top of this library called ipfs-coord for coordination. And I'll talk about that in a second video. So just before I jump into the actual demo of the web app, to give a little background, I have been talking to people about for a while now about how I want to build an uncensorable API, something that can jump over the Chinese firewall and circumvent any attempt at censorship by either corporate or state actors. And so there's a body of knowledge here that I've been working on. This is troutsblog.com. That's my blog, and this is this IPFS API article. So the ultimate goal here is to build an API, which is just a way for two computers on the internet to talk. That's all an API is, where you have services on the left and then consumers on the right. And so it's just facilitating two computers, one that has services that can be provided and another computer that wants to consume those services, probably pay for them as well. How do you make that happen in a way where no third party, like a state actor, can get in between that? So the chat app is really the simplest implementation that I could come up with for this idea, because if you can send strings of text, chat messages between two computers, you basically have everything you need at that point to build an API. So the point here is not to build a chat app. The chat app is just a proof of concept prototype to demonstrate the technology that I'm using to build this API. And okay, so we're just going to cover the demo of chat.fullstack.cash. And again, so because this is a complex concept, I built the app so that I could show rather than tell. And then once you understand like how the app works and how to play with it, then in a second video I'll go through the actual architecture. So first of all, you can get to the app by going to chat.fullstack.cash. And one of the first things that you need to know is that you have to create a wallet. So this is based on our wallet.fullstack.cash web app, which is a Bitcoin Cash wallet. And so if you load the app and you click on the status button to go to the status terminal, you'll probably notice that it'll say error trying to initialize, have you created a wallet? So the very first step is just to go to the wallet menu, click on create wallet. You don't actually need any Bitcoin Cash to use this app. You just need to create a wallet, which creates a Bitcoin Cash address, and then reload the app. And if I go to status, I can now see that it's in the process of instantiating and connecting to the network. The reason you need a wallet is because it uses the Bitcoin Cash address or the wallet to do end-to-end encryption. This app uses the same elliptic curve encryption that Bitcoin uses, and so the same private key that you would use to spend your Bitcoin Cash is the same private key that is used to decrypt messages coming into you in the private channel. So that's the first thing. If you log in, it's not doing anything. That's the first step, is you got to go create a wallet. And then you can keep an eye on what's going on here with the status terminal by clicking on the status button. So yeah, that's just what I said. BCH address is used for end-to-end encryption, and it's there to send and receive payments, but that's not a requirement. So this web app has several terminals, and this is more of like at this point it's more of a debugging developer tool than it is to actually be used as a social media or chat app. But I'll get to the chatting part in a second. So the status terminal is where it's basically getting this running log of timestamps telling you about different events that have happened on the IPFS network. So it's constantly, like every 20 or 30 seconds, it tries to renew connections to circuit relays and to other peers. And you can see here it found a peer, and then that button appeared here with the peer's IPFS ID. And that's how you get into private end-to-end encrypted chats. I'll get to that in a second. So basically, the status terminal is just a log of events of your app interacting with the IPFS network. And then there's the command terminal, and this is again like a really helpful thing for as we develop and on this technology. You basically can interact with the ipfs-coord library with this command terminal. So help will bring up the interactive instructions that you can issue. Clear will clear the terminal. You can do list peers, which will show all the other IPFS peers that your web app is connected to. And so right now there's just one. Here's their ID. These are the different IPFS addresses for connecting to it. When a peer connects with you, it shares its Bitcoin Cash address and its simple ledger address, including the public key that is used to generate those addresses. And this is what's used to encrypt messages. This is the public key for encrypting messages, and then the private key is obviously not shared. And basically, I won't go into any more detail in this demo, but this is basically the fundamental ideas behind how the encryption works. There's also this idea of relays. Circuit relays are required for the web browser to communicate with other web browsers. They can't talk to one another directly. They have to go through a circuit relay that uses secure WebSockets. So right now there's only one, but this is going to expand. And one of the things that IPFS, one of the ways it works is that it gets better as the more participants in the network expand. So as there's more circuit relays, as there's more people using the app actually performs better because there's more redundant ways for data to travel. So anyways, this is the command terminal. So this is a fun way to sort of dig into what's going on. What is this? Pub sub list. So IPFS uses pub sub channels, which is short for publish subscribe. It's a protocol. So this is a list of all the pub sub channels that I'm currently subscribed to. So I'll go into more detail on all this stuff in the next video. I just want to show sort of how to interact with this app as it exists right now. So then there's this all terminal. This is the public chat app, or the public chat room, basically. Nothing's encrypted. Anybody who's looking at the screen will get messages. A message from an automated chat bot just came in. And so what I'm going to do is I'm going to open up another browser window. And in fact, I'm going to do something different where I'm going to open up Brave browser. And instead of... I'm not running it locally. So I could go to chat.fullstack.cash like I said, but instead what I'm going to do, one of the really unique things about this app is it's a native IPFS app. So if you go to the footer, there will be a link here to the latest IPFS hash for this app. And so you can bring that up in any gateway. So apparently I'm having issues with that gateway, so I'm actually going to bring it up with ipfs.io. There we go. So I don't know, for some reason that gateway had an issue. So you can use any gateway. Cloudflare has a gateway, ipfs.io has a gateway. So this is the same app, and it is being, same thing, you got to create a wallet. Oh, it has a wallet. Okay, well, I'll work on that. But for now, I'll just access it the conventional way. But what I'm trying to do here is demonstrate that the app the app lives on its own, and it can be syndicated over IPFS. It doesn't really matter if chat.fullstack.cash goes down. There's no server involved here. And there we go, create a wallet, and then reload. There's no server involved here. The messages are going directly from the web browser to the web browser. And they are navigating the IPFS network, but there's not any one particular server that's important to routing these messages. They can use any circuit relay on the network. And as you leave this app up, they will naturally discover other circuit relays and strengthen their connection to the network after like 30 seconds. Like, it's basically fully connected. So here it is. It's connecting to the network. So I have it. So this is the Brave browser. I have the app running here, and I have it running here in my Firefox browser. And you can see the two peers found one another. And so I can choose a nickname here. So I'm going to call this Firefox. Hello from Firefox. And if I go here, this peer found, like, it got that chat. So again, this is public and not encrypted. So this is clear text. Everybody can see this. Anybody who has this app pulled up can join in on this chat room. There's just one. It's just one public chat room. And so this is just a great way to test it. And what's really convenient about this is, like, if you are like me, where you work with a lot of virtual machines, or just you're constantly moving around from different computers, and you need to, like, pass something along from one computer to another. What's so nice is you can just bring this up in a web browser, which every device supports. Doesn't matter if you're on Android or iOS or Mac or Linux or a refrigerator or a Tesla car. You know, any computer that can open a web browser can access this, and you can just start chatting. There's no sign up. It automatically works. So that's the public chat. You set a nickname. The messages are not encrypted. It's important to know that, and anyone running the app will see your message. Now the private chat, this is where it starts to get really interesting. So if you go to the status window, I'm in Firefox. So I go to the status window. Here at the top, QMVFZ is the ID of this IPFS node. So if I go to Brave VFZ, so this is the peer. This will get better, but right now this is the prototype, the proof of concept. So I click. I'm in the Brave browser. I found my peer in Firefox, and I clicked on them, and this is going to enter me into a private chat with them. And I need to do the same thing here. This peer is UJ8. So I'm going to go back here and find UJ8. So these two peers are now going to have an end-to-end encrypted private chat. So if I go, hi, how are you? So it says me to indicate that in this terminal, it's this terminal that sent that. And then if you go to the other terminal, it'll say the peer. Okay, so the peer sent this. And so the reverse. And so here in this, it says me. And then over here, it identifies that as the peer. So the nicknames aren't really used because there's only two parties in a private chat. But basically, how this is different from the all terminal is there's only two parties involved. What it's doing is that public key that I showed earlier in the command terminal, it's using that to encrypt the message before it sends it, before it leaves this web browser and goes to the network. It's encrypting it with the public key of that peer that you're talking with. And then when the peer receives it, they have the private key, so they can decrypt anything coming in on that channel that's encrypted with their public key. So the message is end-to-end encrypted. There's other layers of encryption. The website itself uses SSL. That's all good stuff. So there's multiple layers of encryption, but it's that end-to-end encryption that basically makes it so that you don't have to trust any of the other encryption. If none of that existed, this whole thing would still be fine and secure because it's end-to-end encrypted, and only the person with the private key to that Bitcoin Cash address can decrypt those messages. And so it's using the elliptic curve cryptography that's native to Bitcoin. So that's the demo of this. The next video that I'm going to create is going to cover the ipfs-coord architecture. Let me just quickly show where that code exists. It's under my personal GitHub account, Chris Troutner, and then ipfs-coord. This is also an npm JavaScript library if you want to find it there. And again, if you go here, there's a link to some of the prior work that I've done in terms of documenting this, the ideas. And yeah, unfortunately, the hash didn't work very well for this. The IPFS hash didn't work very well, but I'm going to be pinning that hash and publishing it. And this app, as it exists right now today, will be preserved and can be used natively on IPFS just through any gateway. If you know the hash, which I believe is right here, QMAYDNC. So anyways, I'll be posting that in the README of the repo. Yeah, and then the actual chat app that I just demonstrated today is also on GitHub under the Permissionless Software Foundation group. It's chat.fullstack.cash, just like the website. If you want to download this locally and play with it, install it locally, that's free to do. Everything's MIT licensed. So yeah, play with this app. Again, mostly this video is for people who already know that I'm working on this, and this is an effort to show rather than tell. So this is a chance for people to just really play with it and understand it at a high level usability point of view before they dive into, this sort of answers the why. Like, why am I doing this? Because I want end-to-end encrypted, uncensorable chat that can then evolve into an API. And so the next video I shoot will discuss the actual architecture, what's going on under the hood here.